this video, we are going to see what are caches and the fundamental concepts behind caching, how we can store and retrieve data from caches. So basically, what is caching? Caching is something like you store some data somewhere close to you so that it can be easy to access, so you don't want to waste time and effort finding the data with a complex query computation or expensive queries. So to give a small example for this, let's say you have a closet in your house and you have a lot of clothes in that, and every time you get ready, you will be opening the door and you will be searching for the cloth you want, and then you will decide which one to wear. But let's say you have a favorite cloth which you use it frequently, and you know that you are going to wear that only for most of the time. So in that case, you can take that particular cloth and you can keep outside the closet somewhere close to you, so that next time you will not open the closet. You will save more time in that. You don't want to search for any clothes, you don't want to open the door, you will go right away to where the place you kept your cloth. You can take from there and then you can use it. So you are saving more time and effort here. That is a similar concept, what we call it as cache here. So there are certain data you need to be like that are frequently accessed, or you need that to be delivered without putting more effort or more expensive computation or queries. So these data will be stored in cache and can be easily accessed by the user. So that is all about cache. So basically you can improve performance here, you can improve time of delivering the data to user. So these are the advantages of caching. And then we have few terminologies. There are more, but few of them is one is hit, which means your request sent to API, and API service checks the Redis database. Sorry, no, it can be any caching database. If the data is available, then it is called as hit, and in case if the data is not available, then it is called as miss. Basically, if there is no data in cache, the requested data is not available in the cache, then obviously it will run the query and it will take the data from the actual DB. So that is the miss. And we have something called hit rate, which means let's say you have 100 requests coming in, and in 100 like most of them, like how many of them took data from cache is the number of hit requests, and if we divide that by total number of requests, then that is considered as hit rate. If your hit rate is higher, then it can be we can say like you have used less DB queries for data, and it has helped in improving the performance and latency of the request. And coming to eviction policies. So eviction policy is something when you will remove the data from the caches. So there are some certain policies here. You can adapt any policy you want based on the use cases. So everything has its own purpose. So we can't say this is the best one or this is the worst one. So it depends on the use case. So based on use case, we'll choose certain policies to remove data from the cache. First one is TTL, time to live, which means a data can have an expiration time. So after a certain expiration, after the expiration time, the data will be automatically removed. And once removed, the next request coming in asking for the data, since the data is not available in the cache, it will obviously go to the primary database and it will get the data from there. And again, if required, we can store it in the cache as well, so that next time it will be accessed faster. Example, we can say like if we store weather data for a particular location, it will be changing after an interval of time, right? So for that we can set an expiration time. So let's say for 5 minutes we can hold same data, and then I'm just giving an example. Whatever the interval is, we can have that interval in the cache, so that for that particular interval of time the weather data can be accessed very faster, and the next after the interval is exceeded, then we can get the latest data and we can store it there in the cache. And next one is least recently used. So this is something, so example is I can say whatever the items that are recently used, not much used recently, we can remove it from the cache. So example is a product catalog. Let's say we have laptop and speakers. So laptop has been viewed recently, but speakers are not viewed like for months. It has not been viewed by any users. So rather than keeping it in a cache, we can remove it from there because it is not viewed by many users. So there is no point in having it in cache. So if anyone needs it, they can directly query the database, and from there we can show the data. And the least frequently used is we can take same product catalog example, where let's say laptop is viewed lesser time, compared to speaker. So speaker is viewed for 1000 times and laptop is viewed 3 times only. So since the number of times viewed, speaker has been viewed in more number of times, so we can keep that data, and laptop is less viewed, so we can remove that from the cache. Again, these policies are you can't use all the policies at the same time for a particular use cases. So it depends. So based on use case, you can choose whichever policy suits for you. And then last one is first in first out. So basically you are removing the old cache data. So if after a certain period of time, we just compare the dates. If that is too old, then we can remove those data from the cache, and we only persist only new data. And still we have few other policies as well, but these are primarily used and kind of more used one, but you can research on that and you can adapt, you can use those policies if required for your use cases. And then we have cache invalidation. So invalidating is this is actually you have a data stored in cache, and it is also available in primary database. Let's say we update a particular data in database, but the cache is having the old data. So in this case, that is a difference. User will not get the latest data, so cache will be holding the old data. So this is called this is where we validate the data and we remove the old data if required. For example, TTL is also part of invalidation. So after we give an expiration time, so after the expiration time the data will be automatically removed, so that user get the latest data. Another way is let's say we update or delete the data from primary database. So in that case, at that particular point, we also update the cache data as well, so that the latest data will be available on the caches as well, and user will get the latest data. So these are the two major primary invalidation caches. And here also we have more strategies on strategies on invalidation, but primarily I think this covers majority of the use cases. And coming to strategies, we have different strategies how we store cache data. Let's say a request first one is lazy loading, which means the request comes in, API checks data in cache. If it is not available, it will call the database query and it will fetch the data, and before returning it to user, it will store that data in cache, so that next time user when reaches the API, it will get the data from the caches instead of DB. So this is how most of the caching, we use in our systems will be lazy loading only, and based on use cases we will use different strategies, but most of the time this would work for caching. And then next strategy is write through caching. This is when you write a data, first you will write data to the cache, and from there you will write the data to primary database. So the disadvantage here is it will take more time, because first you have to write on cache and then again it has to be written on database. So user has to wait until this process completes. So the time to write a data will take more, but we are storing the data first in the cache and then we are moving to the database. So this is write through cache. And we have something called write behind cache, which means it is similar to write through cache, but the only difference is we are not making user to wait here. So it will first store the data in the cache, and to store in the database it will run in the background asynchronously. So we can also have a queue in the back end, so that whatever the number of write query comes in, it will store them immediately in the cache, and in the primary database it will be adding up in the queue, and it will be slowly adding all the data in the backend asynchronously, so that user will not wait for all the database query to be executed and completed. But the problem is, let's say database is getting failure, or the connection is broken between cache and database. In that case, the data will not be written to the primary database, and it will be available only in the caches. So that case will be there will be a data loss. So that is a disadvantage here. And another one is refresh ahead strategy, which means let's say you are getting a trending topic or trending tweet, you will know that this particular tweet is going to be trended soon, so that you are caching that particular tweet ahead of time, so that user will be able to access those tweets much faster when compared to a normal tweet. And also, let's say YouTube recommendations we have. So recommendation, if you can see, mostly the recommendations are very faster. At other videos will be loading slowly, because the recommendations is based on users preference and everything. So it should be delivered at a faster rate compared to other videos. Because of that, we store the recommendation videos ahead of time in the caches, so that people will not wait for this particular set of videos. So that is refresh ahead. And now we are coming into the scaling part. So scaling, we have basically two types of scaling. So one is a vertical scaling and another one is a horizontal scaling. Vertical scaling is simply most of the caches are stored in RAM only. So maybe it is not restricted to RAM, because you can store, you can have your own custom cache as well in any place. So but most of the cache DBs run on RAM. Apart from that, you can have primary database as well as the cache, you can have it, but that is a different topic outside of this video. But vertical scaling is something where you add more resources to the to your server, so that whenever, if let's say you have 4 GB of RAM and you have stored all the cache, you have stored data for 4 GB, so that there will be no more space for new items in the cache. In that case, we will add extra 4 GB. So we will be adding more resources, but at certain point there will be limitation. You can't add more resources. Only a system can have this much number of GBs of RAM. Out of that, you can't add more resources. So that is a limitation. Horizontal scaling is there are different methods here. So first one is read replicas, which means there will be primary cache. Let's say we have a Redis cache, and you can have multiple read replicas, which means the primary cache will have read and write. It can handle both read and write. The replicas will have duplicate data of the primary database, and it will be it can help in handling all the read requests. So it as many requests comes in, so it will be split between primary and secondary, and you have to note that replicas are like only for reading, so it will help to improve the performance when you read the data, not for writing. So writing will happen only on the primary database, and the replica DBs will have the copy of the primary database. So that is read replica. So here you are expanding the database, like you are scaling horizontally. And the other one is sharding. Sharding is simply you will add multiple databases. You'll have multiple Redis service. Here there is no primary secondary kind of thing. You will have multiple Redis, and API will know in which Redis database you want to store which data. So like for let's say for one Redis database we are showing storing profile details, another one we are storing product information. So we will map it inside the API, not so API will know which data should be stored in which Redis DB. So this concept is called as sharding. So sharding is basically you are having multiple databases, so that data can be stored in a horizontal way. So these are the basic fundamentals behind caching, and I have a task for you. If you wish to try how caching, if you want to really understand how caching works in a real time, try building an API server with a primary database, and you can use Redis for caching, and try to experiment with it. Store a data in a database, and when you get the data, try to store it in cache, and again when you try to call the same request, see what is the time difference, how fast you can access the data, and set an expiration for it, and after expiration how the delay is happening, because you will be calling the actual DB query. So just try and experiment on this, so that you will understand caching in a practical way. And you can also experiment with multiple scaling techniques and strategies I have given. So just try it out, and yeah, that's it. So see you on next video. Thank you.